I'm here with Dr. Romano, and we're going to film the second part of the NMR lecture.
Come on around, let me show you a really good problem that I think you'll enjoy. We already did part one of this. Part one, I went over the splitting patterns with you. Now I want to go over two worked out problems. Now, the DAT exam will be a lot easier since the answers will be in front of you. But let's work two of these out. So what I would suggest is try these on your own before you go listening to this tape, and then once you work them out, then listen to the tape. All right. The first thing that I need to do is I'm going to calculate what's called the degree of unsaturation as I've shown in a previous tape. So I'm going to assume you know how to do that. So I'm not going to go over the mechanics on that. So what I'm going to do is calculate the degree of unsaturation first. And when I do that, I come up with 4 degrees after I subtract the H's, the difference, and then cut it in half. There's 4 degrees of unsaturation. Now, when you see 4 degrees of unsaturation and a multiplet or a signal at around 7, this is going to suggest a benzene ring. So I'm looking for a signal around 7, and the degree of unsaturation is 4 or greater. The next thing I do is I look at the IR data. 32 to 3600 suggests to me that there is an OH group present, because that's the alcohol signal. So we now know we have at least 6 carbons out of the 7 accounted for. So the 7th carbon must obviously be attached to the benzene ring, and all we would do is put in our H's, and we would get benzyl alcohol. Now, on the DAT exam, all you would do is check it. You would see that these 5 H's are all approximately the same, so they're going to come in at around 7.28. If you look at this and this, those two would give a singlet, but that singlet would be more downfield at around 4.58, and this signal is always variable. Never trust an OH group. It can sometimes be midfield, it can sometimes be downfield or upfield, depending on the concentration. But in this situation, that was the singlet at about 2.43. I don't think you'll have to worry too much about that, but just be careful. If you see an OH group, the signal could vary. All right, so the answer was benzyl alcohol for that question. Now for the more challenging question. C9H10O. The first thing we're going to do is let's get the degree of unsaturation. So what I do is I get the degree. You're going to double this, 1820. You get 10, cut it in half. That means that there is 5 degrees of unsaturation. First of all, what does the IR suggest? The minute you hear 1720, 1730, that always suggests a carbonyl group. So I believe that there is a carbonyl group present. Now, these are the most important signals. 5 H's multiplet, the minute I see 5 H's, I'm thinking of a benzene ring, and because there's 5 H's, it must be mono substituted. The next thing I look for, I see 9.7, and that suggests an aldehyde group. But be careful, an aldehyde group that gives a doublet must mean that it's next to a CH unit, 1 CH unit. So we know there's an aldehyde group, we know there's a benzene ring, and we know that we have this type of a situation with the aldehyde. The next thing that catches my eye is the 3 H's. The 3 H's would signify there's a methyl group. So let me see if I can just put something together and try it out. If we had something that looks like this, now, if I had something that looks like this, let's take a look at this and let's just check it. Now on the DAT exam, you would go to the answers and you would check it. First thing, there is 5 H's here, and those 5 H's would indeed give me my first signal of a multiplet. The next thing I do is, why don't we look at the CH3 group? This CH3 group you jump to your neighboring carbon and add 1, that CH3 group would give a doublet. And I've justified those two. How about this one? The 9.7 is justified because that's the signal on an aldehyde that you're going to memorize. It's next to 1, so that 9.7 would indeed give a doublet. Now, here's the one that I think's the trickiest. This one hydrogen, there's the carbon it's bound to, has 2 neighbors. It's got a neighbor here. This neighbor has 1 H, and this neighbor has 3 H's. If the neighbors are different, you have to use the n+1 rule separately for each one. So if you apply it to this one, that would give a doublet, and if you apply it to this one, that would give 3 + 1 is 4, a quartet. So you would get a doublet of quartets. Think of the doublet as 2, and the quartet as 4. So that would give you a total of 8 lines. That's always a favorite question from the American Chemical Society. But the bottom line is, a doublet of quartets, you would probably just see it as a multiplet. For the simple reason, as the distance between the peaks, which we call the coupling constant, are very, very close. So the coupling constant is so close, you're going to see this as one big multiplet. But I wrote down doublet of quartets just to make sure you really understand the theory of how I applied the n+1 rule for each one. And there you would have it. I give you this as my proposed structure, and for those that want to do a final name with me, I number the carbons on the longest chain, so you would see that this would be a 2-phenyl propanal. 2-phenyl propanal. I hope this helps on a very challenging problem. I want you to go to the Destroyer book, take a look at the ones in there, but remember, the trick is go to the answers and simply match the answers up to the data and you're home free. All right, that concludes the NMR discussion. I hope this gave you guys a little bit more insight and advantage. Okay, guys, bye-bye.